So I'll be posting those recording sessions in our Google Classroom. Hope you can see my screen. Everyone can see my screen. And you can, yeah, oh, thank you. At any point you have any question, please put it in the chat and I will look every 5 minutes or 10 minutes to answer the questions. So let's get started. Thank you for joining this class. This is a 3-level course on machine learning, and you cannot cover everything in 4 classes. So I made it into 3 levels. Each level has 4 weeks long. So each week is like a Sunday, 1 to 1.5 hour. Yeah, so for some of you, it will be totally a new concept, but don't worry. We will start from scratch and then going into more in depth on those fundamentals. And then we also look at the use cases like a project and how machine learning will be used. So that's how we are going to start this class today. And today we'll be covering a lot of stuff. Today's class is very important because these are the fundamentals. You don't want to miss it. But those who missed the class, you can always go back and revisit the video I will be posting in Google Classroom. So this is, I just wanted to tell something about Robotics for Youth. It's a nonprofit organization, which is kind of giving programs like, training programs, workshops. And we have these classes every other month or every month we will have more classes coming on. So I just wanted to give you and about the, so say something about Robotics for Youth. Okay, so today's lesson, we are going to talk about like the level 1 for class 1. Today, we are going to discuss about machine learning and its applications. Okay, I'm going to get started and this class is recorded. Okay. Okay, machine learning. So many of you heard a lot of these words: artificial intelligence, machine learning, deep learning, data science. So today we are going to discuss the most fundamental things in data science. Basically what is the difference between artificial intelligence, machine learning, deep learning, and how data science is come together with all these technologies. So, just wanted to explain each and every one in detail, less in a couple of minutes. I will just give you a brief overview of these. So I'm just putting a Venn diagram where the artificial intelligence is coming on the top. And then you see the machine learning is a subset of artificial intelligence. And deep learning is another subset of machine learning, and data science is crossing over these multiple, techniques, how data science is coming together. So artificial intelligence is what you know about is artificial intelligence enables machine to think and take its own decision without a human interaction, right? That's what the artificial intelligence on a machine. But then coming to machine learning, so the artificial intelligence is the main goal of your machine learning process. So basically, an example of a self-driving car, and there's a lot of other applications where the machine can take decision by itself. But how do you make machines think and take its own decision. That's where the machine learning, deep learning, and data science comes into place. Okay, so the ultimate goal is to create an artificial intelligence application using these techniques. Hello. I started the class. I won't be able to talk now. Thank you. Sorry, somebody was calling me. So you all understand what is artificial intelligence. Now, getting into machine learning. So what machine learning is, it provides a statistical tool to explore the data in 3 different approaches. So the machine learning is a tool which how the machine learns. So there are 3 different approaches in machine learning: supervised, unsupervised, and reinforcement learning. Those are the 3. So this is basically the machine learning is more about a statistical tool to explore the data, and 3 different approaches. As I said, supervised learning, unsupervised learning, reinforcement learning, right? And we will discuss more in detail on each of these 3 categories, because this is our main class is about. The next one, we are talking about what is deep learning. So deep learning is also like machine learning. So you can teach the machine, but if you can mimic the human brain, like in neurons, how do you think and how do you learn things? How do you learn from, with what we learn, and then keep learning? Like human brain is like that, right? And take decisions on based on that. So there are some different techniques available for the deep learning techniques. It's called artificial neural networks. Then CNN is convolutional neural networks. RNS, recurrent neural networks. So artificial neural networks is used mainly for numbers and words and things like that. But CNN is mainly used for pictures, videos, things like that. And RNN is it's a combination of both too. And the most powerful is the CNN, which is a convolutional neural network, and based on the use cases, right? So, and then the data science is a mathematical tool to solve statistics. What all the tools we use to solve all these problems? Use statistics, probability, linear algebra, differential calculus, extra. So basically, in a nutshell, your main goal is to create an artificial intelligence application using machine learning, deep learning, and using the data science techniques. You are building those. Do you have any questions? In simple words, I try to explain it. So, because you must be hearing all these words, and I wanted to make sure that you understand that first. Okay. Let me go into the chat. Okay, good. Okay, let me go to the next. Okay, so the agenda for this class is what is machine learning. Somebody texted me, they didn't receive. Just a second, let me send the link to the classroom. Somebody said they didn't receive it. Okay, I send it. Okay, so today's class agenda for this class is what is machine learning? I just give you an overview of what artificial intelligence and machine learning, data, deep learning and data science, but we are going to learn more about machine learning and how many ways machine learns and applications of machine learning, and then 7 key steps to machine learning and different models and algorithms. And I will be talking about setting up an environment for you to start working on it. It's called a Miniconda. It's a minimal version of Anaconda. And I'll explain it more about those. This is just an overview. And then we will be touching on a couple of projects, the flower prediction, a simple linear data set, and the diabetes data set, how the prediction will be done. So just give you an understanding, this is the agenda what we are going to cover today's class. So sit tight and then, so, yeah, any questions? Okay. So what is machine learning? So how human learns, right? It's human learns from past experiences, right? You experience some situation, and the next time you go and you are able to predict, okay, this is going to be a problem, and or you are touching a hot oven, and then you know that the first time you touch it, you know it is, oh, this is hot. Next time you won't touch it because you learn from this experience. And the mission also, what mission does is, if human give instruction, the human does it, right? So now what we are going to look at, how mission can learn just like humans. That's what we are going to learn. So every time you have to tell the mission, say, do this all the time. Instead, you are going to teach the human, teach the missions how to react in situations. So you teach them. So that's all what we are going to learn is machine learning, just to give you an idea. Just to give a very simple example, just like in a classroom, you're learning knowledge, you're learning knowledge, right? So think about the books are, you will be learning from books, and there will be a teacher, there is a classroom or an online classroom like this. And then you will have homework, quiz, and finally you have a final exam, right? So in terms of machine learning, these books are your data sets, because that data from the books you're learning, right? The teacher is a data scientist. Just give a analogy, right? And the model is a classroom or an online learning or a syllabus. You prepare it and you train you are training the machine just like teaching. And then you will be testing the model, whether you're doing right, testing the model using homework, quizzes, things like that. And then finally, it is ready for predicting. Okay, you can predict it. So that is an example how I can relate to a classroom, how this machine learning works. So these are the words you will be learning a lot. One, data sets. Second thing is model, training a model, testing a model, and finally deploying a model. So that's how the whole machine learning process. So just give you an understanding. Okay. So basic of machine learning. So I'm going to give another example. So let's say Paul listens to songs. He listens to 4 different kinds of song with tempo, genre, and intensity, and gender of voice. So, but when he listens all this music, he write it down, like whether he likes this kind of song or that kind of song. So let's draw a graph of what he likes. So all these green are the likes for the music he listen. So with his experience, most of the fast songs and highly soaring songs, he likes it. but he doesn't like a light or relaxed songs. So if you put a graph together, you see all the green dots are like all his likings, and the red dots are the ones which doesn't like. So based on that, you can predict what Paul likes, right? If you're, you have a graph, and this is where the data set is all about. You get the data, what he likes it, and based on that, we are going to predict. So with this data set, you are going to train the model. So for example, here, a song, one of the song is a fast tempo, a soaring intensity. It comes into this level, right, in this category. So we have a model, and we are going to predict the song A. The song A is coming into this region of likes. So then you can predict, okay, this song A, we can predict that Paul likes that song, right? And let's say if you go into the next song, like we are predicting next song, it's a medium tempo and medium intensity. But in this case, it lies between these two regions, and that's going to be a little bit more confusing to predict whether he likes it or not, because it's in the middle, right? That is where the machine learning comes in. So basically, this whatever his likes on the songs, the model, learns the model. It started predicting it. At one time, he couldn't predict because it is lying in the middle. And so, that's where we kind of start using the machine learning. Okay. So let's say if you're applying machine learning in this category without knowing much about algorithms and things like that. So the B is lying between the region, green region and red region, right? And then if you mark a circle here, which is the nearest one, 4 likes are nearest for the song B, and 1 red dot, which is kind of a dislike for that song, right? So based on that, you can predict, okay, most likely B, the song B, Paul is going to like the song B. So that's how we predict it. And for example, this is called the K nearest neighbor algorithm. It's an algorithm how you can train the model using that algorithm. That, okay, what is the nearest of the prediction, and you can predict it which song it is, right? That is how it can predict it. So I'm just giving one example, a simple example. Hope you understood. Anybody has any question? I'm just going back to the questions. All good? All right. So now we are going to the next. And this is a small machine learning example I gave, right? But what if the choice become more complicated? Just like what we saw in a small complication arise between the region, the B song, where it is going to lie and how to predict, right? So what it does is it learns the data, build the model, and when a new data point comes, it can predict it. So now with this situation, it learns that, oh, B is a kind of song, he likes it. And next time, if there is another song comes near to B, it knows that, oh, it learns from the K nearest neighbor algorithm, the model can predict easily. So the more and more the data you learn, the more the model become more accurate. Okay. So that's what I said, more data, better model, higher will be the accuracy. It's just a human being. The more you study, the more, the more successful in your career, right? So that's what it is. So now we are going, so all I was giving very simple examples, but now we are going to cover, there are 3 different kinds of machine learning techniques. One is the supervised learning, unsupervised learning, and reinforcement learning. So those are the 3 techniques we are going to discuss in this class. So I'm going to give an example of a very simple example of a supervised learning. Suppose say a person is giving a bag of coin of 3 types. 1, a 3-gram coin, which is 1 rupee coin, and 7-gram coin, 1 euro, and 4-gram coin, 1 dirhams. So there are 3 different kinds of coins in a bag. So in this supervised learning, this is a problem, right? So in this case, the feature is a weight. So when you give this coin and you can just say that if it is 3 grams, okay, I know what currency is it, 1 rupee. If it's a 7 grams, it's a euro, and it's a 4 grams, it's a dirham, right? So the weight is the feature. So the data set has something called feature, which is going to predict based on that, right? So the weight is the feature now, and then the currency is labeled. Okay, it's a 1 rupee, it's a 1 euro and 1 dirham, right? So when there is a label in the data set, then it becomes like a supervised learning. So with the weight, I can just say, okay, this is a 1 rupee coin. It's already written. Okay, all 3-gram coin is 1 rupee. All 7 grams coins are 1 euro because it is labeled. So that is called a supervised learning, because supervised learning has a label associated with the feature. That's what it is. A feature means here the weight is the feature. Okay. So how a computer can predict, or a model can predict the weight looking at the 3 grams, and it knows that this is labeled as 1 rupee coin, right? Okay, now we go to the unsupervised learning. So unsupervised learning, there is no label attached, right? So let's take an example of cricket players. So all we know is whatever score when he bats, what is the score, and then runs, how much runs they are taking, right? Sorry, it's not score, wickets and runs. Okay, there's a mistake here, scores. So wickets and runs. All you know is, I have a data set of all the cricketers' name, and then how much runs they scored and how many wickets they take. So based on that, you want to predict whether this particular cricketer is, is he good in batting or bowling or wicket, based on that, we can predict. During the match, if a new batsman coming out, they can predict using this algorithm, right? So that's what they do. Okay, this person has made so many runs but less wickets, so he is coming for batting, then there is most likely chance that he will score more runs, right? So this is called clustering. So when you put a graph on the runs and wickets, and the people who are together coming here on the y-axis, more runs, less runs, but more wickets. But if you are in the middle, you can see, okay, this guy is a batsman and a bowler. And even if this guy comes in the last man in the order in the cricket, whether he is likely to survive or not, right? You can predict it. So this is called unsupervised learning, but there is no label attached. You cannot say that this person is a good batsman, because while he is playing over the years, his runs will go down. He may be becoming more wicket taker, right? So based on the data, it can coming more and more data, it can predict what kind of how we can predict the outcome, right? This is called unsupervised learning. There is no label associated with the feature. All the feature we have is runs and wickets. So here is an example. On the top is batsman, and this is like a bowler, right? So the reinforcement learning is totally different, right? It's the same thing like learning first, but let's say if your the mission is going to identify a picture of a dog, and based on what the model learns, it predicts it's a cat, because it's this dog looks smaller, but it's kind of like a shape of a cat, but the model predicts a cat, right? But then you said that, oh, no, it is not a cat, it is a dog. And that is where you keep reinforcing the model. Whenever you predict something, it says that, no, it is not a dog, it's not a cat, it's a dog. So that is called it is called a reinforcement learning or reward-based learning. So there will be a reward when correctly identified, there will be a reward, right? If it is wrong, the reward goes down. So that's called the reinforcement learning. Finally, it can predict any picture, right? If this next time, this won't make any mistake because it learns from its mistake, right? So it learns it and then it can predict it more. So that's called reinforcement learning. Okay, to summarize, the machine learning model has input, model, and output. So the input is where you teach the model, and then and once it start predicting the output, and if it is wrong, it gets the feedback and it keeps learning, right? That's what it's same like you're studying for some course and you make some mistakes in the quiz. You made out of 10 quiz questions, you made 4 wrong answers, and you go back and learn, and then you are going to take the quiz, you will most likely to get a 10 out of 10, right? That's where the machine learning process also. Okay, so so you must have got an idea of machine learning has 3 different techniques we talk about: supervised, unsupervised, and reinforcement learning. And let's talk about, there are different scenarios. This is for your homework. Scenario 1, Facebook face recognition. Is it a supervised or unsupervised? Netflix movie recommendation, based on whatever you're watching, it will recommend movies. Okay, this may be a good movie. You may like it, right? And then the fraud detection, like, somebody, try to apply for a loan, and the loan application can detect, hey, is there anything wrong? Or you're having a credit card transaction, and it can find if there is a fraud. Just you can just do it in your go and do some research on, find out whether it's a supervised or unsupervised. And Narsi, do you want to just give some words on the supervised and unsupervised learning? Narsi, are you there?
Yeah, I'm here. Sorry, I was trying to find the unmute button. Thank you, Venkatesh. My name is Narsi Kota. I'm working at US Customs and Border Protection. As Venkatesh mentioned, we are using I'm working as a part of advanced analytics for US Customs and Border Protection. Okay. We are using machine learning techniques to detect some anomalies and unrecognizable patterns. We are using unsupervised learning techniques to detect issues with the passport patterns that are coming from various visa waiver countries. United States issues electronic visas for 48 countries. We don't have their passport data information. In order for us to issue a passport, electronic visa for travelers coming from these countries, we have various checks and balances. One of the check is whether the document, which is a passport that has been presented to requesting the electronic visa, does it fall under the visa issuing patterns for various countries? Since we don't have the actual passport data from these countries, what we do is we use the historical data to detect anomalies and then issuing patterns, and then stop the people taking advantage of passports that they have stolen or passports that they are gotten in their hands without proper authorization, and then trying to claim that they are legitimate owners of these passports, and they try to obtain electronic visa and then come to our country. So we are using the unsupervised techniques, and we have a custom built models using R programming language. We are using various R packages to solve this problem and then enhance travel security for United States.
Thank you, Narsi. So basically, it's a pattern. It was going through one pattern. Everything is going. All of a sudden, there is a new pattern comes in, and that is where the unsupervised learning Narsi was talking about, detect, there is something, a fraud happens, or something different than the normal. And thank you for sharing, Narsi, for an example of this unsupervised learning.
Sure, you're welcome.
Yeah. All right. So now we are going to go into I'm just giving an example. Today's world, we are collecting more and more data digitally, right? The paper days are over, right? Everything is digital. You're purchasing, you're paying through Google Pay or PayPal, or you go to social media, likes, dislikes, all those things depends on digital. Every data is coming as digital. So the good thing about the digital data is where you can collect more data. The more data we get it, the better we learn. The more books you bought it, the better you learn, right? Just like that, more data you can learn from the data sets, and then you can predict more, right? If you have a company, an e-commerce company, you want to predict next month's sales, all right? Or you have a car dealership and you want to predict how the next year is going to be based on the data all around the world. We can predict it. That is where the big data coming in. All these data sets are available. Sometimes things are available publicly. So for example, the COVID situation, like a lot of people, we get the data from different age groups and what are the symptoms, and based on that, the outcome is whether it is a COVID or that person survives. All these rates can be predicted based on the data set we are getting. So the applications of machine learnings are in many different sectors. Healthcare, then sentiment analysis. If a movie is out, and then this can predict whether this movie is going to be in the box office for next 1 month or 1 week, it can predict it. And then fraud detection. If somebody is a cyber crime, you can detect, because as soon as you detect, you have to stop that, right? Otherwise, you will lose a lot of data, or because everything digitally, and then currency, everything, digital currency, everything is associated. So the fraud detection is another thing. Like Narsi was talking about, passport, example. And then the e-commerce, right? So there's so many different applications in different industries. So this is I'm just naming few. Okay. Another example is Uber. When you're, going to Uber, and then it predicts the price based on the demand, the number of cars available in that area, your zip code or your PIN code, and based on the bad weather, the rush hour, whether that road is totally, the price goes up, because in the evening time, if you look at the Uber, the price goes up because the demand is high, the rush hour. How does it predict it? Nobody is going to sit behind this thing and saying that, oh, this is a price you should be charging. No, because they create a model, and that model is becoming part of the artificial intelligence application Uber is making, right? That's how it can predict it. The same thing with buying a car. You are searching for the pricing for the car. The price is derived by so many different factors. The place where you live, the features you are available, so all these things matters. So these are some of the machine learning applications. And I'm talking a little bit more about the Uber model. So now we are talking about three techniques we said: supervised, unsupervised, and semi-supervised, which is the last one we talk about is what is it we talk about? I didn't get the name correct. Or even reinforcement learning. Sorry. Let me go back to this. So all the three we learn, we know the difference between those. And we talk about the applications. And now we are going to talk about various algorithms used for these supervised, unsupervised, or reinforcement learning, right? So I'm just going to categorize that into three main categories. One is a classification algorithm. And then the other one is a clustering. And the third one I saw is a regression model. So those are, the top three I can think of, like the classification, regression, clustering. And under the classification is you do with the decision tree. These are the different algorithms: naive Bayes, random forest, logistic regression, KNN. Then the regression, other regression, linear regression, for example, and that clustering, k-means clustering. And there are so many other algorithms available as more data scientists are coming with more algorithms, right? You can use it. But this is applicable to certain use cases. Some may be good for some use case, some may not be. So just to give you an understanding about what all different algorithms available for machine learning. Okay, so when you are a machine learning, when you are a data scientist and doing some machine learning, so these are the work task you will be assigned with. First thing, you need to collect the data because you need to teach the model, right? So when you're joining a class, what you do, first thing you go and buy the books, right? The material. So that is what you are collecting the data, which is a data set for that particular project. And then once you collect the data and then you prepare the data. So what the prepared data is, you may find so many features. Sometimes some columns or information it is not really matter for predicting for this project, right? So when you are predicting diabetes for a patient, and some information related to that person is wearing a blue dress or a red dress, it is not relevant to that prediction. All the data you need is whether his glucose level, his weight, height, weight, and obesity, and BMI, and all those things are there, right? So when you prepare the data, remove all the unwanted features, unwanted columns, right? And then there are some records where I have a patient information, but this person's BMI is empty, which is not recorded. Then that data may not be good. So you need to make sure the data is all available for the data set. And then the next thing is, once you're done with the prepare the data, then you choose the model. Which model you want to do it, whether it's a supervised, unsupervised, or reinforcement technique you want to use it, and which algorithm you are going to use it, right? So that is where your most of the job is preparing the data and choosing the model. And then you train your model. So let's say you got 1,000 records of diabetes patients, right? Out of this 1,000 records, you will keep 800 of them for training, and 20 you keep it for, okay, let's say 600 you do for training the model, and then the 20 you are trying to test the model. And then after the test, you can all the rest of the 200, you can try predicting it and then see whether you are able to predict correctly, and then it is ready to go. And then you see how accuracy is, the prediction is, then based on that, we can fine tune that model. Then you are evaluating, that is what I was talking about, evaluating finally, and then you are fine tuning it. And then you have to create an interface. Interface means a web page where, okay, input your BMI, your glucose level, and then it will say, okay, according to the model, it is predicted that you don't have diabetes, right? So like that. So these are the 7 steps. When you are a data scientist working on a machine learning, these are the 7 major steps you will be working on. If it's a big team, there will be a team will be collecting the data. There is a team preparing the data. Then there is a team who is doing the step 3 and 4. And then 5, 6 is another person. And the 7th step is somebody is developing a model to predict, right? They can interface for that. Okay, hope you understood that. So I'm just giving an idea of different models. We use it. So supervised, unsupervised, and reinforcement are techniques, but models are the one we are talking about, different algorithms. So giving an example of a price prediction, when you're predicting a price, logistic regression is the best model which suits for price prediction. If you are doing a classification, then fully, for example, networks, right? So if you wanted to classify the network or the users you want to classify, then the fully connected networks classification is a good algorithm to use it. And then convolutional neural networks is for image processing, image detection, things like that. That's for neural networks, which is CNN. And recurrent neural network is for voice recognition. And random forest is for fraud detection. Reinforcement learning is learned by trial and error. Generative models and image creation. K-means is segmentation. K-nearest neighbors is recommendation systems. The Bayesian classifier is spam and noise filtering, spam email filtering, things like that. So these are all some examples of models related to the applications we'll be using. So, but you don't need to learn all of them, but start from one place and then slowly understand the different models and algorithms and understand the concept. You will be able to work on any kind of problems. Okay. Now we are going into basically how the lab is how you are going to start working on a machine learning process. So all you need is to install Anaconda. Anaconda is a distribution of Python and R, because both are kind of used for data science, scientific computing. Miniconda is as a miniature of Anaconda. So for you guys to learn, Miniconda is easy to install and start working on it. So I'm going to show you how we can download, install, and I have put everything in this document. So you can go into the Google Classroom and see how to do it, and then you can install it and start using it. And then Jupyter Notebook is another tool for collaborating. So for writing the code and sharing the code between your groups, Jupyter Notebook is something which you will be installing. So you'll be installing Miniconda and Jupyter Notebook. So just want to give an understanding of what is Miniconda. Just, you don't need to go much into details. So the Conda is basically has all the available packages installed. So if you are started working on a linear regression or you are starting on certain things, all those packages are already installed in Conda. Otherwise, if you are started working just on Python, you need to install that and things like that. But this will be having everything in one place where you can start working on it. So installing Miniconda, and I give instructions. You go through the this URL and then just click install, and it's pretty. You have the Windows version as well as Mac. I will encourage you to install the 64-bit. Most of your Windows 10 or other machines are 64-bit machines. So you can install that. It's pretty simple. It will take around 2 minutes or so. So these are the questions it will be asking when it's installing it. So first you said next, and then I agree just for me, and then it will show you which folder you are going to install it, and then just go. Don't add the path here because it can give problems. Just leave it like that, the default, and then go and install it. So this is a 6-step process. It's anybody with your eyes closed, you can install it. So I highly encourage you to install Miniconda in your laptop. And then once it is installed, Miniconda will be completely installed, right? And then you have to add the path manually. So I give some instructions how to add the path. And it's pretty simple. I just go through the steps you want to do it and click add and add the path here. So that's the one task you need to do after the installation of Miniconda. So after the Miniconda is done, I have a video, I put it in here, and it talks about step by step. You can just watch it and how to install Conda and Jupyter. So basically all the steps are here in this video, but I just want to give you an idea. Once it is installed, you go through the command prompt, and when you say activate, it goes to its own base. Let me show you what it is. Command prompt. Activate base, and it will go into the Conda's command prompt. So from there you can this is what I was talking about. Type activate base and just put command like update Conda all. It will update all the packages. And then the next one is Conda install Jupyter. So when you install Jupyter, it will go through the process. It's in the command line process. So all these things are available in this video, but just go through it, spend an hour installing everything in your laptop before the next class. Okay. Now we are going to go into how this Jupyter Notebook, and we still have 10-15 minutes. I'm going to go over how the Jupyter Notebook, we can just do a simple hello program, and then from there you can start working on the project, which is a classification of flowers, right? So once you have a Jupyter Notebook, so this is a Jupyter Notebook, and this is going to be a website which is localhost. When you are opening a Jupyter Notebook from here, you can say Jupyter Notebook. When you click it, it's going to come like this in your browser. So in the browser, you can create your own, you can create a new program, just like new and Python, right? So I have one already here, Hello World. So I just wanted to give you an idea of what Jupyter Notebook is look like. So in new Jupyter Notebook, these are all called cells, different cells. You keep adding more cells. So you can put your command here and run this command, and it is going to display the response immediately after that. Okay. So print hello world, print. I'm just going to do the same command here towards the last. I'm just going to give here Python data science, machine learning. When you click run, it will send the result back here. So it's a very good tool where multiple people can collaborate on that, working on the same project. And say print hello world, and then I can do 1 plus 1. What is the result at 1 plus 1? 1 plus 88. What is the result? It's going to give you 89, right? So this is called the Jupyter Notebook, and this is where you can start working on a model, creating a model, and I'm going to explain it with the first project. Okay, so you can try yourself how once installing, and I'm going to upload these programs in the Google Note, the Google Classroom, and you can try out. Okay, now going into a project, we are going to go into the project. This is a project which is predicting the flower. You have some in your cell phone, you can install an app like predicting which kind of flower it is, or which kind of plant it is, whether it's a good plant or a bad plant, or a weed or something. It's the same kind of similar kind of model we are talking about here, but our model is going to predict 3 different species of flowers. So there are 3 different flowers in this project. In this case study, it's called sedosa, versicolor, and virginica. There are 3 different flowers. All we have the data set to learn for the model is the petal length. Petal means what? What is a petal? It's the flower's petal, right? The petal length, petal width. Sepal means the sepal is under the flower. You have this kind of a leaf, right? Not leaf, there is in between the stem and the flower. The sepal length and sepal width. All we have those 4 attributes. Attributes means the features. We will call as, in the data set, we have 4 features, and we know what the species is, which is going to be a class, because this is a supervised learning, right? It is a labeled program. So we have the data set, and I'm going to show you what data set we have. So all we have is, yeah, I can just open it in Excel and then show you a better way. So this is our first machine learning program. And it is taking time. Okay, I think it is, my Excel is having problems. So maybe. Okay, so let me go into that Irish data set. So this is the data set. You have a sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width, and then the species called Irish sedosa. Okay, the Excel is open now. I don't know why it is taking so much time. Okay, so look at that. So we have, don't worry about the ID. We have 4 features, which is, when I open both of them. So the sepal length, sepal width, petal length and petal width. We have how many data we have? We have around 150 data to teach the model, right? And we have, if the length is 5.1 and the width of sepal width is 3.5, and then 1.4 petal length and 1.2 width, then it is Irish sedosa, right? Like that, we have Irish versicolor, and then Iris virginica, right? There are 3 flowers we have data set. So this is where we are going to teach the machine learning process with this data, and later it can predict it. Just like the Paul, I was talking an example with, 4 different kinds of music he likes. based on that we are predicting. The same way we are predicting the species here. So this is our class. This is what we are going to predict it. But for us, we have 150 rows to teach the model, right? So that's what it is. Okay. So we are going to start working on this particular model. How the first thing what we need to do, we already talk about machine learning, or sorry, data science is all about understanding the data more, right? So to understand how the data is here, so that I can create a model. So I cannot just say, okay, oh, you give the data set and I'm going to write a model. I am so good at models and I can just create a model and then, okay, start working on it. No, it needs to understand the data more clear. And first you need to understand the feature, what is a class. Okay, those are the things you need to be working on. So I created a project called Irish project. So the way I was doing is you can just create a new Python and it creates a brand new project for you. You can start working on it, right? So I already have one which I already created. So this I'm going to close this. So here I have a project, and this is for, okay, let me look at that. Irish project one. Okay. Okay. So there are some libraries we'll be using it for our purpose. So just familiar us with that. We can go detail into it. So first we need to import some libraries. So in this case, and I'm going to explain a little bit more. I'm going to do the import NumPy. These are like math libraries where you can, the data, load the data and find all the statistical analysis. Pandas is another one. And then Seaborn is another library where you can load some data sets. Matplot is for graphing techniques, so different graphs. So we'll be using these libraries in one way or the other way. So I'm going to explain it more in detail. So first I'm going to run this, and then I got this. I'm just printing the versions. So this version of NumPy is 1.20.3, Pandas is 1.3.4. Seaborn is 0, 11, 2, and 3.97 is another one. So basically, it's kind of like a library. We are uploading it so that we can start working on it, right? So just skip the Google Drive, and I'm going to go into loading the data. I have already downloaded the data set, which is iris.csv, which I showed you around 150 records. I just run it. And this is once the pandas. So one more thing I want to explain is import pandas as PD means PD is what we are using it for. That is the nickname. I'm going to use it more. Like once you start using pandas, you can put any name like PD1, PD2, anything. So I'm just using import pandas as PD means once we are using pandas now for loading the data. Data frame equals pd.read CSV. Read CSV means it's an Excel file in a CSV format, comma delimited format. When I'm loading the data into this memory, this is DF is the, so now DF is the memory where the whatever data is read from the CSV and put it into the data frame. This is called a data frame for Panda. So there are some commands you can look at it. Okay, I want to see how how the data looks like. Okay, I have, so it will show you first 5 records. So it will say, okay, sepal width is this, and so the first 5 rows it is going to show, and I can do more more looking at the data, whether it's already uploaded correctly and things like that. But then the column names, I wanted to put it in totally in a readable format. I can just put a column name and assign the column name to it. So you can just run this. And again, I'm loading it. I can see the column width correctly. Okay. And also the Seaborn also has a data set. You can load it from there instead of from CSV. Okay. So next one is very important. In the data frame, I want to describe the data. So what is description of data means? Looking at the data, how many records we have? 150 records. What is the mean, means average sepal length, sepal width, petal length, and petal width? Then what is the standard deviation? And I'll give you some another class. I'll show you what a standard deviation is. But just understand, it will give you some information which is going to be helpful for coming with what kind of model you want to do it, right? So this is called the data exploration, right? Looking at the data, how the data looks like, whether it's a linear, is the data is linear. Linear means it goes through the x-axis and y-axis. It goes in a straight line, going up or going down. And then, it just describe again, it gives you all those information, all the statistical tools, which we talk about data science is all about, right? And then it is also have other options where group by species, what all the different species I have. So this command is going to give you some idea of each species and how many species are available in that record set. It is a data set we have, right? So next one is we are going to graph it. So what the graph is, okay, let me run through it. Okay, visualization is happening now. Okay, so what the visualization is, we have 4 different attributes or features. So sepal width against sepal length, sepal, like that. It's all the 4 different combinations. So if you look at the model, depending on the graphs, what matplot is giving that option to do that. And you see all the blue are kind of on one side. If you see that, it is distinct, right? The blue is, coming little bit outside from the other 2. So that means the blue is the sedosa can easily predict with the data what we have. But the red one and the green one is basically looking at the, the data, those are kind of like one example I said with Paul liking the song, there is a medium intensity. It can go in both sides, right? Like that. So it can be in both sides. That's where machine learning is going to help more on that. But this is where you can see how the data is arranged, whether it is the data, we can see which model we can apply to predict this particular use case, right? So this blue is coming on the left side. So that means this is a one, at least out of 3, 1 is easily predictable, but these orange and green are not. So, and then you do some histograms. Histograms are showing how the distribution of data is, with each feature. The sepal length is like, in different 0.65, there are, with the sepal length of 6.5, there are 26 of them, like that. So it will give you an understanding of the data. So it's called exploring the data. And there's another plot diagram will show you uniquely that, these are the 3 species, and these species are coming to this, but these 2 other species you can see are kind of little bit kind of similar, but it is, the green one is little bit away, but you can start predicting which feature should be used. So in this example, petal length is a good feature which can distinct it, this one I was talking about. So finding the feature is one of the main main task in building the model. Okay, so there are different plot diagrams. So just you don't need to get confused with that, but I'm just giving you an example of how data is loaded in Jupyter Notebook and then start analyzing the data, right? So that's what the in a first notebook Jupyter Notebook program, you start looking at the data and then see how you can understand the data more clearly. If you don't know about mean, median, mode, and also standard deviation, I am going to put another document. It's pretty simple. How to mean is nothing but take the total of all the data and then divide it by the number of records, right? That is mean. Standard deviation is basically each and every item, what it difference from the mean, and then square up and add it and taking the average. So that's what it is. So don't get confused. I'm just going to give you an idea. So be prepared for the next class with more projects we are going to start working on. And I'm going to give you another example of a data set from diabetes data set. So we have a data set, a diabetes data set, we are loading it. And diabetes data set has a lot of, let me show you the information about a patient who is diabetic or non-diabetic, and then how you are predicting it. So I'm just opening this data set. Take some time. Okay. It's opening the data set. Or I can do from here, diabetes data set. So diabetes data set has, pregnancies, then glucose level. Okay, here we go. Glucose level for each patient, right? The blood pressure, skin thickness, insulin, BMI, diabetes functions, blood functions, age, and outcome. Whether it is a diabetic or a non-diabetic, right? So we have around 768 patient data we collected, and based on that, we are going to train the model and then start predicting it. So so here in this, the first thing what I told you is there are a couple of steps. You are collecting the data and then analyzing the data here, and then you are training the data. So this is the training. So we are setting apart 20% of the data for training or testing. Minus 20 means 80%, and then test 20% is testing, right? So you can slice the data using these libraries. Then we will slowly learn those things, but don't get stressed out of all these things. This is totally new for you. It will take a little bit time. So in this case, we are using a linear regression model. So this is the model, like an algorithm, we are going to use it. And then you are fitting, means we are training this model here. And then you are predicting the model. So this is what the model is going to be started predicting. These are all the black dots are the patients, but the people who has diabetics are more or like near to that line, right? That's what it is, right? So these are all the process. First, you get the data and load the data, analyze the data, and then train the data and test it and predict it. So that's all the whole machine learning process. This is one example I gave you, but we are going to cover a lot in next classes. So just to understand, while showing this, just to understand that a data set is a collection of data, real life data, right? And here in this data set, what all the features? Sepal length, sepal width, petal length, and petal width are the features, and species is a class. Okay. And this is one example I gave. Diabetes data set is another thing. And then once you start doing this, Kaggle has a competition available. They give a lot of data sets. You can look at the data set. You can come up with your own machine learning algorithm, and you can submit your the competitions. If you go to this competition, there is a lot of competitions available, Kaggle, or you can look at the data, at least understand what the whole thing is about, because you are not yet there, but there are so many different competitions available here. They give the data set also. Okay. So next week's topics, we are going to cover more about once you install Miniconda and Jupyter Notebook, we are going to start working on taking different use cases. We will work on a classification algorithm we are going to do. And we are going to cover a couple of a regression model and then the classification model. And that's coming next week. But before that, be prepared, install your Conda and Jupyter Notebook, get ready, and go through the material one more time. Make sure that you understand the material clearly. And I know it's going to be new for everyone. So next week there won't be a class, but I'm keeping an office hour. So anybody has question one-on-one, I can answer next Sunday at the same time. I can answer any of your questions. And if you have difficulty in installing Miniconda, I can answer it. And then after that, we will have regular classes. Like 27, we will have classes, and 27 and 6th and 13th. So 4 classes, we will be finishing at least the classification and regression model. But hope you understood the topic we covered. Just to summarize, we talk about the difference between the foundation of what artificial intelligence is, machine learning, deep learning, and what data science is. We just go through it. If these are the things you should understand. With all these words, people get confused, right? So, and we talk about different techniques, how machine learns. I just give some examples. And we talk about how you predict, how do you train that model, and then we talk about many ways machine learns. Machine learning 3 techniques: supervised, unsupervised, reinforcement learning. And then we go in detail in supervised, unsupervised, and reinforcement learning, and little bit more in detail. Then I have a homework quiz for you. These 3 scenarios you should, and I'll post a quiz over there so you can understand that, and then go Google it and then find what model we are using it, technique we are using it. And then different applications we use it, and different algorithms we use to build those models, and 7-step of machine learning model. And we talk about Conda and Jupyter Notebook. And we also looked at Jupyter Notebook in a very high level on different projects, right? So now it's a time for question. Do you have any questions? I know we covered a lot of things. I tried to make it very simple so you can understand. You can chat here. Narsi, you wanted to say something, just to how importance of machine learning is, the job opportunities and things like that.
Yeah, there's a lot of job opportunities in this space. First one is, as you guys know, data scientists. Data scientist opportunities are there where people who are familiar with all these algorithms, as well as some of the programming languages, either it's a Python or R. Um, there are opportunities there. And there are also lots of COTS products in the industry that helps to develop machine learning models. Some of these COTS products are on the cloud, like you guys have heard about AWS SageMaker is there. There are some COTS products on Azure space. Google has their own COTS products are cloud-based products on GCP. There is a data robot. There's a lot of open source products like H2O. There's also data engineers who are available, who are needed for these analytics or predictive models projects. The data engineer's job is pretty much once a data scientist explores and then comes up with the data that is needed. There's a lot of data munging needs to be done. That's done during the model development. Once the model is developed, the model has to be put into production environment where the data has to come in, and then a lot of data engineering, data pipelines will be built that are all data engineering positions there. There's also application engineer positions there. Once you develop the model, you have to create web services or some kind of interfaces. The data model does not live by itself. It has to be configured such a way that it will talk to the upstream decision-making applications. There will be web services. There are MQ interfaces where the payload comes in. In our case, it could be a simple passport number or a shipment ID, a traveler that is coming into the country or going out of the country, or if looking into a mortgage industry, it could be a applicant social security number or applicant's name, date of birth and social security number that comes as a payload. And then if you built in a model which predicts whether we should take his application and process his application or approve his loan, you take the payload and then go across the data systems that you have, get all the data that is needed, basically the features, right? Then you predict the model and then give the decision back to loan officers to approve this loan or not to approve. So there will be a lot of extended functions. One of the function could be, let's get his credit score. The application or the whole application will be calling a credit score application, getting the credit report from 3 credit agencies, and then treating that as a feature. There's a lot of opportunities out there, both in private and federal government sectors.
So to become a data scientist, maybe you can start with Python. R is another language, but Python is a good to start, right, Narsi?
Yeah, Python is very easy to learn, and then there are a lot of packages that Python has come up, and there's a lot of literature out there. R is a little older program in the sense like, R has been existed for quite some time. It derived from another programming called S programming. Both are equally good, but both have the Visual Studios, or there's R Studio, but easy to learn is Python. You have a lot of resources out there on the internet, and then even in schools, high schools as well as colleges, Python is well accepted as a data science programming language.
Yeah, so learning Python is a good thing. And if you are new to this class, I have another class which just finished last week. I uploaded all the 4 lectures just to understand the basics of Python. Then we'll be learning more about how the pandas and the NumPy is used. That is more important for data science project more than Python. But we'll be using, Python is basic thing you need to learn. And then understand the, different techniques and try different use cases by yourself. and then look out for any real world examples of data where you want to predict it, and you never know whether you come up with a model which will be becoming, you never know that's going to be purchased by other companies and becoming, part of a bigger product. But learn this is going to be a future. All the banks are using it, energy industry, healthcare. Predicting a cancer is another big healthcare model, where it can predict whether, looking at the pictures and photos, it can predict whether there is a cancer benign or cancer cell is there. So there is a lot of applications in manufacturing. It's all IoT sensors which collects the data, and then we can create a model to predict the outcome of what need to be done immediately. There's a lot of things in data science where you can learn. So this will be a beginning, and as today we cover this many topics, I know there's a lot we covered. But go through this document which I uploaded, and the video also will be uploaded. Hopefully everybody gets an idea. Mani, you want to say some last words?
Thank you, Venkatesh. It was a great presentation. And thank you, Narsi, also giving you your insights from your real world experience. Now, everybody, so now Venkatesh gave the fundamentals of data science. This is a very good class. You need to go through it again. And so if you don't understand this very well, it will be very confusing in the future classes. So it is a 4 weeks class, and it's not a very detailed class. It is just we are touching everything. So it is you need to take your efforts and spend some time in between. And as Venkatesh told, install all the software required and continue with that. And as Narsi said, there's a lot of job opportunities in this field. And US government said there won't be enough people. They'll have a difficulty finding people to work on data science for the next 20 years. Okay, so now there's a lot of demand for this. And data is a huge issue here because we are collecting a lot of data. Now, analyze and get the needed data, it's a lot of work involved. And so data science is growing field, and machines are still learning, and humanoids are coming. So the biggest problem is that a huge amount of data, means terabytes of data are available there. Now, what is required in this maybe less than 1% is what we needed. That is where all these machine learning and everything is coming. Okay, so
yeah, to add to that, right? Data science, artificial intelligence, all these algorithms, these are all developed, if you look at it, in 60s and 70s or even 50s, 1950s. But some of these have not come into real life usage. That's because a couple of things. One, the machines that we had those days, not powerful enough to do. And also we did not have so much data. If you guys remember the mainframes, we were writing programs to always save the data, like how much storage I could save by using, COMP4 or some of these data types and formats. But data storing has become so cheap with the help of the commodity servers and all the open source. You must have heard, like with the Facebook and then Instagram, there is enormous amount of data, petabytes of data generated. If you look at the statistics, the amount of data that gets generated by each individual on a daily basis is huge. The data centers. So data collection, writing data is very, very cheap. But you collected all this data, but how do you take advantage of this data? And then how do you help to solve the real business problems or health problems or environment problems? That's where the data science, machine learning, deep learning, all these techniques and then areas are coming into picture. Every industry is going to use the data science techniques and algorithm to solve the problems. I mean, we use artificial intelligence and data science related methods every day of our lives without even knowing that there is a data science or there is a machine learning model behind it. That's how this penetration is. There's a lot of opportunities. In fact, I've been looking to recruit data scientists, junior as well as senior data scientists or entry level for last couple of months. It's been very, very difficult to find right people with the U.S. citizenship, and then there's a lot of opportunities, guys. And this field is just getting scratched.
Thank you, Narsi. And Uma, thank you for joining. Uma, I didn't see you. So Uma is going to give some use cases, not today, in another class, how the documents can be using the AWS SageMaker, how we can build a model and then show an interface, right, Uma? One of the class.
That's what the idea is.
Yeah. Thank you, Uma. And Sudhakar, you joined. Thank you joining, Sudhakar.
Thank you, Angie.
All right, so thank you everyone, and I'm going to post this video, and please, before the next class, install Miniconda and Jupyter Notebook, and then try some of these projects I will be uploading today. So try to learn it, and yep, that's it for today. And thank you for joining the class, and keep learning.
Thank you.
Thank you, sir.